All right, moving on to problem C. So C is going to be similar to the other two problems in that they do equal a constant. They're equaling a number. So what I'm going to do first is circle just my base and my exponent, kind of like I did on A, I circled just the log, and on B, I circled just the base and the exponent. So here my base is 6 and the exponent is 2x plus 1. And eventually I'll want to get to x, and to do that, I'll have to turn it into a log. But for now, what I can do is move the 4 over. So I'm going to start with that. I'm going to move the 4 over by subtracting. So subtracted on the left side, it's going to be wrong. Subtracted, or wrong, gone. And I'm just left with 6 to the 2x plus 1 power, subtracted on the right side, and I get 115. So again, this whole thing is circled, which means this is all stuck together. So the only way I'm going to be able to get to that x right now is to not have an exponent. I will need to turn it into a log. So the first thing I'm going to do is write the word log. And the base of my exponent is the log. This is one where I can show you the e6 to the, then 115. And then that's going to equal the 2x plus 1. So again, some of you have the new operating system, some of you have the old operating system. I'll show you with the old operating system what you'll do. You'll be typing in log 115, close those parentheses, and you'll divide it by log 6. You'll want to close those parentheses, and that's going to give you some number. But as far as typing it in right now, I'm going to use the newer operating system. So again, what I can do is just press math, scroll up, and choose that log base and put my little 6 in, put my 115 in, and I'm going to get a really long decimal, but for the sake of keeping things on track, I will round that decimal as I'm writing. So I get this long 2.6 something. So I'm just going to write down the shortened version of this, but I'm still going to have that long decimal in my calculator, because now what I'm going to have to do is subtract 1. So I'm going to subtract 1. And that's going to give me a very similar long decimal. And now to get x alone, now I'll divide by 2. So keeping this long decimal in my calculator, I'll just divide by 2. And when you're done, rounding to the nearest thousandths, that'll be 0.824. So that is my answer for C. All right, D, moving on to D. All right, sorry, a little technical difficulty. All right, so here, same idea. I will want to solve for x. I notice that it equals a constant, so eventually to get to that x, I'll have to turn it into a log. So first I'm just going to circle the base and the exponent because these are stuck together. And with that, I will be able to move the 3 over. So I'm going to move the 3 over to the other side by dividing. So on the left side, I am left with 4 to the x power. And when I take 2,352 and divide it by x on my calculator, I get 784. So now I'm ready to get to the x. The only way to get to the x is if the exponent is not there. So I'm going to turn it into a log. So I'm going to write the word log, then the base of the exponent, 4, then 784, go to the other side of the equal sign, equals x. So at this point, again, some of you will have to type this in the long way, like this. Make sure you close those parentheses. The others can just press the math buttons. Whoops, that should be normal size. Scroll up and just type it in. And when you do rounding to the nearest thousandths, you get 4.807. All right, moving on to E. E is a log problem. So again, what we need to discuss, which I don't think I did in A, is with logs, you can't take the log of a negative number. So I will have to check for extraneous solutions when I'm done. But starting with E, this is a little different between F, because on E I have a log equaling a log, and on F I have a 2 logs, but it's equaling a number. So how I solve E is going to be different from F. So the fact that it's just on problem E, a log equal a log, means I'll be able to cancel the logs out because they have a common base, but I can't do that until that 2 is dealt with. So what I'm going to do is, if you guys remember those properties of logs, this 2 can come back and become an exponent to that 1/2, like this. And if you guys remember, hopefully you've talked about that a squared is just the exact opposite or inverse of a square root. So that squared will just cancel out that check mark, that square root, so that in the end, on the left side, you're just left with x. So now to solve for x, what does x need to be so the left equals the right? Well, if you just ignore those logs, that x needs to be worth 12. So the question is 12 a solution or is an extraneous solution? So if you take 12 and put it back in here, would you be taking the log of a negative number? And you wouldn't, because the square root of 12 is 3 point something, and you can take the log of 3 point something. You won't get an error message. So E, that's your final answer. All right, on F. So because this is equaling a constant, what I'll eventually need to do is turn this into an exponent. But I can't turn this into an exponent until I have one log over here. And right now I have 2 logs. So what I'm going to do is condense that down into 1 log. So if you just ignore those logs for now, remember that that plus sign in between will become a multiplication sign. So it'll become x, this x right here, I'll put it in front, times x plus 5. I'm going to go ahead and distribute that through. And so now I've condensed the log down. I just want to make sure that I bring the log back. And that will probably be a very common mistake, as we forget to bring the log back after we condense it down. So I've gotten the left side down to 1 log, and here's the right side. And this is all part of the log. So when I'm trying to get to x, this is all stuck together. So the only way to get to x right now is to not have a log. I'll turn it into an exponent. So it's going to be 6 to the 2nd power equals all that stuff in the parentheses, because that's all part of the log. All right, 6 squared is just 36. Moving over here. And going back to first semester, what you need to remember is that when you have more than one type of x, that's what I say to my students, you just can't get x by itself. We're going to have to factor. And to factor, you're going to have to get into standard form. So I'm going to move the 36 over, because standard form equals 0. And I'm going to move the 36 over by subtracting. This is just what in my class we call easy factoring. What are factors of negative 36 that get you to 5x, and that's going to be 9x and 4x, and I'll make the 4 negative. And then I can go to my easy factors, x plus 9 and x minus 4, and now I'll solve by what makes my factor 0. So right now I have negative 9, and I also have 4. So what I need to see now is, are either of these an extraneous solution? So if I take those solutions and I put them back in the original problem, hold on. Would I be taking the log of a negative number? Because you cannot take the log of a negative number. So if I first put negative 9 just into here, I'll have log base 6, and negative 9 plus 5 is negative 4. And this won't work. That's extraneous. Even if you put it into the other part, I can't take the log of a negative number. So negative 9 is what we call an extraneous solution. Technically, it's not even a solution. So what happens if I put 4 into all of these things? So I'm just going to do a little erasing. So if I put 4 into the first part right here, 4 plus 5 is 9, and I can take the log of 9. And if I put 4 in here, I can take the log of 4. So 4 is the solution because I'm not taking the log of a negative number, and that is the only solution. All right, moving on, G. So similar to F in the fact that I have 2 logs over here. So what I'm going to do first is take those 2 logs and condense it down into 1 log. So just ignoring the log for now, that subtraction sign is going to be turning into a division sign. So it'll become 56 over 7, which I could just turn into 8. And now what I want to do is, don't forget, it's not 8 equals x and you're done. Don't forget that there is a log that I was temporarily ignoring. And now I'm going to solve for x. So this might throw you off because we're not turning it into an exponent. You can actually just go straight to your calculator now and type this in. Some of you can press the math button, scroll up. The rest of us might have to do this. But when you take log 8, close the parentheses, divided by log 32, close the parentheses, or you press the math button and scroll up. When you type this in, 1 second, I'm gonna use my calculator. Sorry, I thought I had the answer already. I don't. I'm going to get 0.6. And that is the answer for x. All right, moving on to the next problem. So again, a little different than the one above, f. It's more similar to the one with e in the fact that I have a log on the left side, a log on the right side. So I want it to just be a log equals a log, which means I'm going to deal with this 1/4. It's going to go back as an exponent. All right, so now that I have that, since I have a log equaling a log on the other side, and they both have the same base, I can just basically ignore those logs, and x will be whatever 81 to the 1/4 power is. So you can go to your calculator, type that in. Maybe you remember from freshman year that a 1/4 power is like a 4th root. Either way, you're going to have your calculator and you can type this in. So let me show you that. So if you're going to do 81 to the 1/4 power, some of you, depending on the operating system, might want to put that 1/4 in parentheses. Whoops. I technically, on this operating system, don't need to do that. Whoops, but I am not getting the division sign. Or I could do 81 as an exponent and turn it into a decimal. Or if I know that it's a 4th root, I could press 4, press math, scroll up to option. Whoops, that wasn't the. Choose the 5th option, put in 81, and I'll get 3. So either way, any way that you do the problem, you are going to get 3. So when I'm done, my answer is 3. So it's a log problem. Let's just double check that it's not extraneous solution. So if I put 3 back into here, in for x, will I be taking the log of a negative number? No, I'll actually just be taking the log of 3, and that's fine. Okay, so that one has no extraneous solutions. All right, these two problems, and then I'm going to switch over to the graphing. My graphing problems are a little different than some of the other teachers, so you might not be hearing my voice in the next video. I don't know. All right, so when I look at I, so again, I have a log problem, and since it's equaling a number, eventually what I will be doing is turning this into an exponent. So the first thing I'm going to do is, like I did in the other problems, I'm going to circle the log. So the log has this x minus 1 behind it. So what I need to do first is move the 3 and the 5. So I'm going to start by moving the 5. They added 5. I'm going to subtract 5. So the left side becomes 21. The right side, I'm going to put a little dot in there for multiplication. Again, this part is still circled. So now I'm going to move the 3. The 3 is multiplying. When you don't see a plus or minus, that implies multiplying. So I'm going to divide by 3 on the right side. That's going to make the left side 7. And now I'm ready to solve for x. Again, I can't get to x because it's part of the log. So the only way to get to x is to not have a log, so I'll turn it into an exponent. Remember, there is a little base here that we are not seeing. There's an understood e here. So I can go to my exponent, e, go to the other side, to the 7th power, come back to the original side, equals x minus 1. So e to the 7th, you can type that in your calculator. Remember, just do the second ln. That's the easiest way. So e to the 7th power is a pretty big number. Well, it's not too bad. But my answer is going to be whatever e to the 7th is. And then from there, subtract 1. That's a minus sign. So when I'm done with e to the 7th power, that's about 1,096. Subtract 1. And my decimal, well, it's supposed to be a 0, to 3 places is this. This is my final answer. All right, J. So